Warm greetings to you all. I'm Chaithra and my friend Akshaya has prepared a presentation and I'll be explaining it. So today let us learn about a very interesting topic, that is refraction. So what exactly is refraction? Let us look at its definition. The definition states as such: the phenomenon of bending of light when it travels from one medium to another medium of different optical densities is known as refraction. So it is nothing but the change in the direction of light ray when it moves obliquely from one medium to another. Note here that both the medias are of different optical densities. Optical density is the speed of light in two medias. So we have three cases here. So let us study each case. Case 1 is when light travels from a rarer medium to a denser medium. So here the speed of light decreases and the ray bends towards the normal, and the angle of incidence I is greater than the angle of refraction R. When we switch the medias, we get case 2, that is when light travels from a denser medium to a rarer medium. So here the speed of light increases and the ray bends away from the normal. As seen, the angle of incidence I is lesser than the angle of refraction R. Case 3 is a special case when light travels along the normal. Here, the light ray is incident normally to the second medium. There is no bending of light taking place, but there is a change in the speed of light as expected. Here, angle of incidence I is 0 and angle of refraction R is also 0. So the next topic here is our laws of refraction. So the first law states that the incident ray, refracted ray and the normal to the interface of any two given mediums all lie in the same plane. The second law, popularly known as Snell's law, states that the ratio of sine of angle of incidence I to sine of the angle of refraction R is a constant. So the expression for Snell's law is given below. Sine I by sine R is equal to n to 1, where n to 1 is the refractive index of medium 2 with respect to medium 1, and n to 1 is same as n2 by n1. So the final expression is given as n1 sine I is equal to n2 sine R, which is important. Snell's law fails at case 3 because here angle of incidence I is 0 and also angle of refraction R is 0. So therefore sine I by sine R is not defined. Moving on to the next topic, that is normal shift. So here's the video demonstration about it. So let us look at its definition first. The apparent shift in the position of an object placed in one medium when viewed normally from another medium is called normal shift. So let us understand this through a diagram. This diagram is from the textbook. So here an object is placed in the denser medium and we are viewing the object obliquely from the rarer medium. So when light rays pass from denser to rarer, they bend away from the normal. So when we produce the refracted rays backward, they intersect at a point, and this is the position at which the image of the object is obtained. It is raised and is above the actual position of the object. Since our eyes always perceive rays of light coming from a straight path, we are able to see the object here and not here. Normal shift depends upon a few factors. Let us study those. So factor 1, it depends upon the refractive index of medium in which the object lies. Factor 2, the distance of the object from the refracting surface. 3, wavelength of light illuminating the object. 4, refractive index of medium from which the object is viewed. Refractive index of medium n is equal to real depth by apparent depth. Here, real depth is the actual depth from the surface, whereas Apparent depth is the depth which is visible to human eye due to refraction. So the next topic here is lateral shift. Here's another video demonstration. My friend here has used a crystal to demonstrate this experiment. The line drawn here is the emergent ray. And the incident ray is being extended. So the distance between these two rays gives us lateral shift. So the definition states as such: when a ray of light passes through a parallel-sided glass slab, the perpendicular distance between the emergent ray and the incident ray produced is called lateral shift. So let us understand this through a diagram from the text. Here, when the light ray travels from a rarer to a denser medium, it bends towards the normal, and again, when it travels from a denser to a rarer medium, it bends away from the normal. So this will be our incident ray, and this will be our refracted ray, and this ray which is emerging out is known as the emergent ray. The dotted lines represent the incident ray that has been extended. So the perpendicular distance between the emergent ray and the incident ray gives us lateral shift. Lateral shift also depends upon a few factors. Those are the thickness of the slab, angle of incidence, refractive index of the material of slab and the surrounding medium, and also the wavelength of incident light. Moving on to the last topic, that is applications of refraction. So we have two applications stated below. First one, the apparent shift in the direction of sun, and hence 2 minutes apparent delay between the actual sunset and apparent sunset. So here during sunrise, the light ray bends due to the thick layers of our atmosphere, and we see the sun early even though it is just below the horizon. Similarly, at sunset, due to the same bending of light, we see the apparent position of the sun and not the actual position. The second application, that is the apparent flattening of the sun during sunrise and sunset, also carries the same principle. So that's about it. I hope you all understood. Thank you.